Okay, now we were discussing the sludge production and nutrient requirement. Here, when we consider the volatile suspended solids, that is, the sludge production is in the order of 0.01 to 0.1 kg of volatile suspended solid per kg COD removed. Then the typical arrangements. The raw sewage coming to the plant is first screened and grit is removed. The flow is then taken to the distributing inlet chamber, from which the several vertical pipes take the flow down the Uasbr reactor of 4 to 5 meter deep for BOD values of 200 to 300 milligram per liter, in bracket it is written, and release it uniformly to the lower part of the reactor, allowing it to rise at a desired velocity up to the outlet, which is at the upper periphery of the unit. That is written there, is it? Now look at this picture again, the sketch. So now what is written here? It is written here that when we the inlet we are taking from the inlet is coming from the outlet of the grit removal chamber. That means before the wastewater enter into the UASB, we are taking the wastewater through the screen to remove the floating matters, when the grit chamber to remove the grit particles, and from the outlet of the grit chamber, the vertical pipe is taking down the flow to the bottom of the UASB, then the wastewater is lifted up to the top of the reactor, where the outlet is there, where the outlet is here. So this is the outlet, two outlets, that means along the periphery of the reactor or the container, is it? So that is written here. So remember, here the wastewater is directly coming from the grit chamber. There is no primary sedimentation tank at all. Okay. Now coming to the next one. That is then again here it is written that normally a BOD value of 200 to 300 milligram per liter, if it is there, then the USB reactor is of 4 to 5 meters. That means the vertical pipes which is taking the flow at the bottom of the reactor, it has to lift up to a height of 4 to 5 meter, which is usually the height of the reactor for a normal BOD value of 200 to 300. And you have to provide a velocity so that the flow will reach up to the top of the reactor where the outlet is there. And now the USP process, then again it is written, in USP process the whole waste is passed through the anaerobic reactor in an upflow mode with hydraulic retention time, that is HRT of 6 to 12 hours. That means within 6 to 12 hours the flow will reach the top of the reactor. When it enters into the reactor and when it leaves the reactor, it will take around 6 to 12 hours. And again it is written, no prior sedimentation is required. That means there is no primary sedimentation tank at all. And the upflowing sewage itself forms millions of small granules which are held in suspension and provide a large surface area on which organic particles or organic matter can attach and undergo biodegradation. So that we have already discussed, the organic particles which is passing through the biomass, it is coming through the, when it is passing through the biomass itself, the organic particles are undergoing decomposition, and there in that case the organic particles itself is providing a space for the for the microorganisms to attach there and undergoing decomposition. Okay, so now again it is written there, suspension and large surface area organic material. Then it is written a solid retention time 43 to 50 or more days occurs within the unit itself. That means even though the HRT, that is the hydraulic retention time, is 6 to 12 hours, that means the effluent will enter and exit. It